Hello, welcome back to Cracking the Cryptic, and today was the day when we released the Jewels of Osiris, the brilliant story stroke Sudoku hunt, well, a combined Sudoku and treasure hunt created by Demono, who has written over 27,000 words of a story there, and it's all interwoven with a Sudoku hunt. It's just class in a glass. It's brilliant. Do check it out if you're with us on Patreon. Join us on Patreon if you haven't already, or if you've lapsed. This is the time to get back in and have a go at that. Now, we're not going to be doing shout outs for the winners. We're going to be doing a scroll of honor at the end that we put up on a video to reveal everybody who got through it, because we're expecting hundreds of you too, and poor old Simon has to read out names otherwise forever. So that's what we're going to do at some point. Also, the final answer to the hunt requires you to come up with your own suggestion, and we'll be judging the winner based on those suggestions, and Demono will help us with the final 10 or so. We're looking forward to that. It's going to be really interesting. You've got till the 20th, so do consider joining us on Patreon if you like a good treasure hunt, and who doesn't. Now, what else have we got going on? We've got all our apps, of course. Do check them out. We are Simon's Friday crosswords still going. On Patreon, you can see my monthly Very Difficult Times, monthly special crosswords. Loads going on around the channel. There's also Sven's Sudoku pad, the catalogue of our puzzles, our merchandise. Just check all the links under the video, where we do try and also squeeze in the chapters now as well. So you can just jump to when the puzzle starts. This puzzle, I should have mentioned, is clearly just an arrow Sudoku. So there we go. If you know what arrow Sudoku is, you can just plunge straight in. If you've got our app of arrow Sudoku, you may be familiar with some of the techniques and tactics. Let's hope they are useful today. And yeah, okay, so the puzzle is by Rodrigo Mahu, who we have featured at least a couple of times on the channel before. Is a very erudite South American constructor, I believe. We have 1 to 9 in every row, every column, and every 3x3 box. That's normal Sudoku rules applying. Along an arrow, the digits add up to the number that's in the circle. So those 3 digits will add up to whatever's in that circle. Digits can repeat on arrows if allowed. I reckon that arrow and that arrow are the only candidates for that. But give it a try. It's the first link under the video. I am going to reset my clock and start now. So let's get cracking. See how we do. To give myself the illusion of progress in an arrow Sudoku, I like to just fill in digits, circles that have to be at least 6. Why do these ones have to be at least 6? Because there are 3 digits that have to be different on their arrows. And 1, 2, 3 are the minimum on the arrows, so these add up to at least 6 in the circles. Now, I'm not seeing a lot of other stuff in this puzzle. Now, sometimes it's quite good to look at combined arrows. So, for instance, we might look at columns 7 and 8, where we have all of these arrow cells. Now, the minimum that they can be, there are 5 of those in column 8, so the minimum they can add up to is 15. 4 in column 7. The minimum total of these arrows is 25. If we add on another 1 and 2 in column 9, that's 28. Oh, that's no use. We don't just have those 4 circles. We have this one counting twice. Okay, that wasn't a very enterprising or useful way of looking at this. These have to be at least 5 to have 2 different ways of making up their arrows, especially as they're in the same box, but actually it could be 5 with a 1, 4 and a 2, 3. It's not that helpful. Okay, this is clearly a tricky puzzle. I don't know what to do at all here. Is this colouring? Is it set? I am struggling to see how we can make any progress in this. Okay, I need to have a good cold think. There's quite a bit of symmetry. Okay, here's a set thought. Is this any good? Right, I'm going to share a secret with you to start with. And it's this. Every row, column and box in a Sudoku adds up to the same number. And that number is always 45. Yes, it is, because by rule, each row, column and box contains the digits 1 to 9. They always add up to the same number, unsurprisingly. That number is 45, the 9th triangular number. So these cells, these blue cells, obviously add up to 45. Now, I can commute those two numbers. This one is obviously the same as these three. So if I make those blue and that one not, well, now still my blue cells add up to 45. Let's do the same on the other side. Those blue, that one not. Now this is getting more interesting. All the blue cells add up to 45, and you'll notice there's not just 9 of them anymore. There's now 13 blue cells because of the effect of converting from the circles to the arrows. So these have to be 6 different numbers that add up to at least 21, the total of 1 plus 2 plus 3 plus 4 plus 5 plus 6. So do these. I think they can share numbers. That takes us to 42. And that is the minimum total of those 12 cells. To get from 42 to 45, we need to add whatever is in here. So this is 1, 2, or 3. It can't be any higher. And that's a finding that you wouldn't have had without a bit of set theory, I think. And that means this number can't be a 6, because that can't be a 1, 2, 3 triple. I mean, this is not huge. Removing one candidate at a time is not the way to solve this, but maybe we're learning something. What's going on at the top here? What is it that is special? Oh, let us think about repeat. Yes, let's think about repeat digits on these arrows. Oh, this is interesting. Okay, my first assertion is going to be that there is a repeat digit on these arrows, because if they were all different, those would be 6 different cells. They would add up to at least 21. That would have to be the same total as these 2 circles, which is the other representation of the totals on the arrows. They cannot add up to 21 or more because their maximum is 17, which is actually 4 away from 21. So all I've learned is that there is a repeat digit on these arrows. Now, yeah, that is very interesting, because where does that repeat digit go in row 3? All we know so far, I'm not really thinking about what number it is, but all we know so far is that there is a repeat digit in these cells. So it appears once in row 1 and once in row 2 in those boxes. In row 3, it must go into these cells. Now that repeat digit cannot be a 6 or anything higher, obviously. 6 is the highest number you could put on one of these 3-cell arrows. If that was a 9, this could be 1, 2, 6. But if that was a 9, this can't be a 9. And then you can't put a 6 on the other arrow. So 6 is not the repeat. The repeat digit is here. Now, what is that repeat digit? That's my next question to myself. Do I know what it is? Right, let's just think about this total again. So Those three, okay, let's now assume, oh, I have to be very careful of one thing. Yeah, okay, it's okay. No, sorry, I was just thinking, could there be a repeat of that on these arrows and a repeat of 6? But no, we've just established there isn't a repeat of 6, so it's okay. 7, 8, and 9 can't go on these arrows at all. Right, so these are 5 different digits and 1 repeat digit, because only this is the only one that can be the repeat digit. The other 5 all have to be different, because if there were any other repeats, they'd have to share this cell, which is nonsense. So there are 5 different digits and a repeat digit. 5 different digits have to be 1, 2, 3, 4, 5. That's already 15. Add on the repeat digit. Well, we're only allowed to go up to 17 because of the total of those two. And that means this is now 1 or 2. These add up to 16 or 17 and don't have a 6 and do have a 9 in. So these cells are either 1, 2, 3, 4, 5, 1, and then we get a 1 here, or 1, 2, 3, 4, 5, 2, and then we get a 2 here. For 2 to be the repeated number, then 1 wouldn't be the repeated number. One of these sets would have no 1, and that would be a 2, 3, 4 set. The other one would have a repeated 2, oh, it would be 1, 2, 5. Okay, that does work. Right, this is now 1 or 2, and this can't be 7 anymore, because that would have to be a 1, 2, 4 set, and you couldn't fill that digit. Now 1 and 2 are going to have been used up in these 4 cells, because one of them has to be in this group. In fact, the fact that that's 1 or 2 means this can't be 1, 2, 6, or indeed 1, 2, 5. However, well, the digits must come from digits from a population no higher than 5. Now, I'm not sure. The set theory wasn't really what did it. It was thinking about repeat digits. I don't think the set theory is going to give me anything else. Maybe I should get rid of the blue colouring. One and 2 have been used up. What about this one? Oh, look. Is it? Now, I'm going to get very confused here. Is this a similar setup down here with these 3? Or that? Oh, I'll tell you what. No, I don't know. I'm trying to think. What about repeat digits in the yellow? I'm not. I know that thinking about repeat digits in the yellow might be important, but I don't see why digits can't comfortably repeat in the yellow. Yes, I do. It's the same thing as why they can't be here. Okay, I think we've got a different situation. Up here, we could only have 1 repeat digit because 6 was not possible, and that repeat digit was going here. Down here, I think we could have 2 repeat digits in these yellow cells. And they could fit into these 3 cells with one of them there and the other one in whichever circle is lower. Now, what am I talking about there? Well, whichever circle is higher, imagine that one of these is a 9. That 9 cannot appear in any yellow cell. And that's because it couldn't be on its own arrows adding up to 9, and it couldn't be on the lower digits arrows because 9 would obviously break those. So even if the higher digit is an 8 or a 7 or even a 6, that thing is true, that digit can't be on any arrows. And therefore one of these 3 cells can't contain a repeat. So I think there's a maximum of 2 repeats in the yellow cells. And they must go in these green cells. Those 2 repeat digits, if there are 2. There might only be 1. Can there be none? 1, 2, 3, 4, 5, 6, 7, 8 adds up to 36. But remember, that's not the total of these two. We're doubling them because they've got 2 arrows each. No, that is too much. 36 is just too much. These would both have to be 9s. Because then each circle would have 18 in its yellow cells, and they'd add up to 36. So there is a repeat, and that is in a green cell. Now, can it be the lower number? This is the other thing I'm wondering. No, it can't. The lower number can't be a repeat, because although it could be on the higher number's arrow, it can't be on its own arrow. So I'm imagining that was a 5 and that was a 9, say, for these purposes. Well, the 5 could be on one of the 9 arrows over here, but it can't be on the 5 arrow. So the lower number is not a repeat. So neither of these are a repeat, and therefore this cell is the 1 repeat digit that we're allowed. Is that right? I think that's right, that the yellows give us 1 repeat digit. And we've worked out that 0 repeat digits is impossible. I think this is right. Yes, the lower number can't possibly have the repeat. It's good. It's all good. I didn't have to worry about higher and lower. Just the fact that you can't put a digit on its own arrow means that neither of these could be a repeat digit. I'm sorry, I'm not sure why that wasn't obvious to me now I think about it. It seems totally obvious now, but it wasn't. Anyway, we got there. I know Simon did a puzzle at one point where it really mattered considering the lower and the higher digits in arrows of some sort. Anyway, it's not this one. This is the repeat digit in yellow, in these yellow cells. And now, what are we allowed? 1, 2, 3, 4, 5, 6, 7 adds up to 28, plus another 1 is 29. We halve that to get 14.5. These have to add up to at least 14.5 and therefore more. So now we know they add up to 15 or more. So we can take 5 out. Is that all I get? 1, 2, 3, 4, 5, 6, 7 is 28 plus a repeated 1. No, this can't be a repeated 1 because 1 and 2 are gone in the column. That is at least a 3. Right, now we're up to 31 from these digits, allowing for the repeat to be at least a 3 to fit in here. Now 31 divided by 2 is 15.5. So these have to add up to at least 16, so we can remove 6. Now they're adopting a certain similarity with those. They add up to at least 16, and the similarity goes further because there's definitely a 9 amongst them. And now we've got an X-wing on 9s, and that is a 9. There's our first digit in the grid. The 9s in these rows must be in these cells. We've worked that out. And therefore these are the only 9s in columns 4 and 6, and they are the 2 9s for that. So the 9 in column 5 is going to have to be in box 5 and is there. Now that's not the most helpful digit. It doesn't tell me, well, this is either 1, 3, 5 or 2, 3, 4 now. So there's definitely a 3 in it. So now this is not a 3. So this has gone up to at least a 4. And that means these numbers are at a minimum 1, 2, 3, 4, 5, 6, 7 and a repeat 4. Well, that adds up to 32. Divide that by 2 and that's 16. And those can be a 9-7 pair with the absolute minimum numbers on their arrows. 1, 2, 3, 4, 5, 6, 7 and a repeat 4. So the 9 would have a 4, 5. The 7 would have a 4, 3. Now, I think this probably has a maximum of 6. So imagine these were 1, 2, 3, 4, 5, 6, 7 plus a repeat 6. That would take us up to 34, which is the maximum here, 9, 8. So I don't think the repeat number can be anything higher than 6. Wow, okay, this is complicated. I don't know what my next step is. Oh, I'll tell you what, I do know something absolutely weird and fascinating. These 4 cells, they clearly contain 2 9s, but they don't contain 2 of another digit. They don't contain 2 8s and they don't contain 2 7s, because otherwise you'd have to fit an 8 into one of these cells, or a 7. So these definitely contain 2 9s, an 8 and a 7. Now, maybe I didn't understand enough at the top of the grid. Maybe I can work out whether this is a 1 or a 2. Is that right? No, I worked out a way it could be a 2. We'd have 2, 3, 4 on one of these, 1, 2, 5 on the other. Yeah, I don't think that makes these impossible. So, no, okay, not that. Oh my goodness, where does 9 go in this row? Look at that. Oh, that's mad. 9 can't be in these cells because the 9 in this box is in one of those 2. It obviously isn't on one of these yellow arrow cells, and it's also not on that arrow cell, or you'd have to get at least a 10 into that circle. So the 9 in row 7 is placeable. Now, 9 can't be here because we've got a 9 pair there. It's obviously not on this arrow, and now it can't be here. So 9's in one of those cells. I think by exactly the same method, it's now not here, so it's in one of those 2. That might be the end of my fun with 9s. No, it's not. Where's 9 in the bottom row? Remember, that's a pair, so 9 can't be in these cells. Can't be on a yellow arrow. It's got to be here in the bottom right corner, and that fixes 9 in box, whatever that is, box 3. Ah, now 9 in column 7. Can't be here by sudoku, can't be here by arrow, and is there. It carries on. I place 9 here. Am I finished with 9s? Apart from the X-Wing, I am. Okay, whoa, hurrah. The puzzle has 9 in the title, so it's nice to get. It has 1 as well, so maybe 1s will be important too. Now, let's think again about these yellows. Oh no, let's think about 8s. Right, one of these circles is either a 7 or an 8. For that circle, looking at the box into which it points its arrows, where is 8 going to go? Oh. No, this doesn't work so well. If it is an 8, 8 would have to go into one of these corners. Oh, if this was a 9-8 pair, I can place 8 there, because 8 now can't be here, because that would have to be a 9. Oh, come on, think of... I don't know what I'm meant to be thinking about now. Right. It doesn't work. One of these is 8 or 7, and I was just trying to work out... In one case, it can go on an arrow. Oh, does it have to? Let's say this was 9-8. Well, you can put an 8 here. It doesn't matter whether it's... Yeah, this is right. I think this matters. If this was a 9-8 pair, you can't put 8 in any of these cells. The 8's in rows 7 and 9. One of them can be on an arrow to a 9 circle there. But the other one has to be in one of these two cells, and it can't be there if it's an 8. Now the same is true of a 7 right up till that point. If this is a 9-7 pair, one of the 7s can be on a yellow arrow, but the other one is going to have to be in one of those two cells. Now, if this other digit that's not a 9 in the circles is an 8, we know it's there. But if it's a 7, it could be here. Now, I can tell that means there's an 8 in one of those two cells, and I don't think that's going to help me solve anything. I need to find some way of disambiguating these circles. I was nearly there. It didn't quite work, did it? Right, whatever the digit that goes with 9 here is, it's got to be in twice in those 4 cells. So in one instance, it'll be forced into the to the end column. I don't know. I don't think that gets anything done. Ah, ratatouille, come on. Bobbins, bobbins, bobbins. I don't know what to do next. I don't think there's any other places where these repeat digits are so interesting. Now I'm starting to wonder about where 8 and 7 go in this column. Well, one of them's in that box, whichever one is allowed to be by those, and one of them's in this cell, whichever one is allowed to be by those. Is that right? Yes. 8 and 7 can't go both into those cells, or this would be an impossible foursome. So one of them is here. So that is 7 or 8, and now we've got 7, 8, 9 triple. And now has that done something to one of the cases? If this was 9, 7, that's an 8. No, if this is 9, 8, we said that is an 8, and that's a 7, and this is the 8, 1 pair. But if that's 9, 7, this is an 8. I don't think it does the job. 8 must be on one of these arrows. I sort of think I might have proved somehow that one of those two arrows contains the 8 or 7 that gets on an arrow. Maybe I just need to think about these numbers. If we have 1, 2, 3, 4, 5, 6, 7, which add up to 28, this is either 4 or 6. For this to be a 5, these would have to add up to either 32 or 34, counting 5 twice. So then there'd be 1, 2, 3, 4, 5, 5. I think there'd have to be 6, 8 at that point. I think that, unfortunately, I think that does. I think the only way this is a 9, 7 pair, that's a 4. Wow, what else happens then? It's quite interesting. If that's a 9, 7 pair and that's a 4, this is 8 because of the 9, 7 pair. You've got 8, 4. This now must be 1, 3, 5, 9, 2, and a 7-6 pair at the top of the column. But it could be 9-8. It could even be 9-8 with a 4 here. I'm so close to getting into this properly now. 27 minutes in. I've got some 9s placed. It's not the end of the world. It's about these yellow cells, isn't it? It's not these other arrows, I don't think. Oh, I didn't think about doing the set theory at the bottom. It's not going to prove anything different, is it? If these add up to... Now I do need to think about this. Let's say that was 9-7. Let's say that was a 9-7 pair. This has to be 4 to allow the yellow digits to have the repeats. So that's a 9-7-4. The rest of this row adds up to 25. These yellow arrows add up to 32. Because it's 16 doubled. That's 57. Plus 9 and 9 gets us to 75. These two cells would have to add up to 15. And you can't use a 9. They'd have to be a 7-8 pair. If this was 9-7-4, that can't be an 8, so that would be a 7, and that would be an 8. Okay, what happens if these are... That's the only way this can be a 9-7 pair. All of that becomes true. I'm just going to pencil mark the 7 and 8 that result from that. Now, if this is 9-8 in the circles, let's just do that on its own for the moment. Well, no, it matters what this is, doesn't it? Let's say this was a 6, which would then be the repeat digit in here. Anyway, if this is 9-8, the yellow cells on the arrows add up to 34. Plus 9 and 9 is 52. Now these, in row 8, add up to anything between... So I've got 52 already. They add up to anything between 24 and 22, depending on what this other yellow cell is. 52 plus 22, 74. 74 to 76. These remaining cells have to add up, to make the total of those two boxes 90, to somewhere between 14 and 16. And that's in the extreme case, I think. Well, no, it's in all cases. 14 in one case of 4. Well, 14 if that's a 6, I think. Anyway, they add up to somewhere now between 14 and 16. Because in the 9-7-4 case, it was definitely 15. Well, given that none can be higher than 8, they must be from 6, 7, 8. This one can't be an 8. That's a 1 or a 2. This is a 7 or an 8 now. I still don't feel I'm very close to a break-in, weirdly, here, after all that. To the break-in of this part of the puzzle, anyway. Oh, what about the third digit from 7, 8, 9 in this row? Yeah, I don't know. I don't know quite what this is doing. I think there's a there's a holistic calculation here. I'm not 100% sure that this was right. I think it was. I think what I've said is genuine, but I'm getting a bit lost now. Ah, my goodness, this is an absolute brain fryer. Come on, Mark, think it through, think it through. For that to be a 6 at all, this was going to be an 8, and this was in the case where they could add up to 14. With these adding up to 34, and these 18. That's 66. These were 24 then to get the total to 90. Plus 9, 8 here. Is 41, and that's a 4. So the only way for this to be a 6. Hang on, I'm saying these have to add up to 14. I was about to conclude this has to be an 8, but why couldn't they both be 7s? Oh, I don't know. I'm getting so stuck in my brain now. Okay, I'm going back to these digits. These were either 1, 2, 3, 4, 5, 2. Well, I was going to say they were either 1, 2, 3, 4, 5, 1 or 1, 2, 3, 4, 5, 2. But actually, they could be 1, 2, 3, 4, 6, 1. That's quite annoying. Oh, I cannot see my way out of this impasse. Can I rule out 6 from here? I don't know. This is either 2, 3, 4 or 1, 3, 5. If this is 2, 3, 4, that's a 1. And this is 5 or 6. If this is 1, 3, 5, that's a 2. And this is 4 or 6. I feel like I'm right on the right lines, but I cannot quite see how this works. Oh, goodness. What is going on? What is this pair? This pair... is it a 9-7 pair? I just doubt that it is, but I suppose one of these pairs has to be a 9-7 pair. I've worked that out. The trouble is, even if I find out which one, the rest of the puzzle may be an absolute monster still. Rodrigo, what are you doing to me? So, one of these is going to be a 9. The other one is lower. Did the yellow cells have to have one of the lower one of these on them? I don't think they did. They have a repeat digit, which is either 4, 5 or 6. Oh, goodness, I don't know. Oh, hang on. Where's 8 in this row? No. Yes. Yes. Where's 8 in this row? That's a valid question. 8 cannot be in these 3 cells because that's a 9, 8, 7 triple. it's not allowed to be there because this can't be a 9. 8 in this row is on one of those two yellow thingies. So 8 and 1 are definitely in this row. I thought I'd worked that out before, but I hadn't worked it out in that way. So that's not a 1. One of these is a 9. Oh, now there's an 8 in these yellow cells. Now the minimum they can be is 1, 2, 3, 4, 5, 6, 8 for the non-repeating ones, which add up to 29. Plus the repeating one, which is at least a 4, adds up to 33, and that doesn't allow this to be a 7-9 pair. So they're not 1, 2, 3, 4, 5, 6, 8 with a repeating 4. They're either 1, 2, 3, 4, 5, 7, 8 with a repeating 4, or 1, 2, 3, 4, 5, 6, 8 with a repeating 5. But this is not a 6 now. So now I have got a 1, 2, 3, 4, 5 quadruple. These are from 6, 7, 8, 9. And one of them's definitely a 6 in those. I thought that was going to help me. It doesn't look like it helps me at all. But. These are now the 8-9 pair. These cannot be an 8-9 pair, or 8 couldn't go anywhere in the central column. So they are an 8-7 pair, 9-7 pair. These add up to 16. They are 1, 2, 3, 4, 5, 1 with a repeat 1, and that cell is a 1. There's no 1 on this arrow, and therefore it's a 2, 3, 4 arrow, and this is now a 5, and therefore 5 is the digit that repeats, and these must be 1, 2, 3, 4, 5, 6, 8 and a repeated 5. Can I do more with that? Well, they don't have any 7s on. Oh, this has become a 7 because of the 9-8 pair. Does it resolve? Yeah, come on, do the maths again on the whole box. These add up, these yellow cells add up to 34, 17 times 2. They add up to 34, plus 9, 43, plus 9, 52. So those all add up to 52. These add up to 45 minus 22 is 23, plus the 52 is 75. These two add up to 15. They are a 7 and an 8, and we know the order because that can't be an 8, and that's it. Oh, that's taken a head-wreckingly long time. But that's progress. That, my friends, is progress. Oh, what have I done there? That can't be a 1. This can't be an 8, therefore. Oh, these can't have an 8 on at all. This is 1 and 8. This is where the 8 goes. That means this is the 9 arrow. This is 8. This is the 9 circle at the top. That's a 7. This is now a 1, 2, 4 arrow. And the 1 is in the corner. No party for you. Only got one corner left for a possible party. And that corner is not a 1. So it's narrowing down. In fact, we know that these were 1, 2, 4, 1, 3, 5. So this is a 1, 3, 5 triple. Ooh, so we've got 50% chance of a party there. Now, that means that 2 and 4 are in these cells. I was about to say neither can be in the circle, or 2 can't be, but I think this could go 2, 1, 1. So 4 could be in the circle. 3 and 5 are over this side. That can't be a 3. This arrow has to add up to at least 5. Oh, and look at the possibilities for this cell. 5 or 6 out of the remaining possibilities, I would say. So there is definitely a 2 on this arrow. It's either 2, 3 or 2, 4. Oh, look, there's a 5 down here. That's a 5, 4 pair. There's an X-wing on 4s, so there's no 4 on that arrow. Oh, isn't that lovely? Look, we get a 5 in the circle. That looks down here, 4, 5. That looks up here, 4, 2. I was going to say that looks across, but it doesn't. But the 2 looks down, 3, 2. Oh, gorgeousness. 6 and 7 to finish off column 8. 3 and 2 to finish off box 9. This isn't going to fall apart now. I doubt it. 5 has to be on those cells. That's a 2-6 pair. This is a 1-3 pair. That's not a 3. This is a 2-4-6 triple. That can't be 2. Now, in this box, that is a 6 naked single. That's a 4-5 pair. 3 and 6 go up here. We knew 3 was in one of those cells. This is now 8 and 7. We can do those. 8 and 7. This is coming apart. This is amazing. That's a 6. This is not. This is a 2-4-6 triple now. That one can't be a 2. 8 and 7 are resolved. That 7 makes that an 8, which that did ages ago. I just didn't spot it. 7 can't be there. Now, this is 4 or 6 on what has suddenly become the only remaining arrow to clear up the candidates. That's so bizarre as well. Now, 4 would go 2, 1, 1. 6 has more options, but... Oh, are there any X-wings? Yes, look, there's a 2 X-wing. One of those in row 3 and one of those in row 9 is a 2. So in fact, that 4 possibility is not right, and that's not a 2. So let's just get rid of that. This is now a 6. There's no 2 in those cells. There could be one here. If there's no 2 in these two, they add up to at least 4. They can't add up to more than 5. There's no 2 in them. So it's either a 1-3 or a 1-4 pair. There's definitely a 1 in use. This is 1 or 2 to make up the balance to 6. Have I not got another X-wing? Oh look, that's become a 2-4 pair. Oh, here comes another X-wing. There's a 1 on one of those cells. We've positioned that. There's definitely a 1 in one of those two. That's using up the 1s in columns 2 and 3. So the 1 in column 1 is this here. Now I've got a 4 X-wing. Look at that. There's a 4 X-wing, and this can't have a 4 on it. That is a 1-3 pair. This becomes a 2 to make up the balance to 6. This is a fantastic puzzle, Rodrigo. You are an utter genius. Oh, I love it. I love it. I love it. Now, that is not a 3. Oh, look, 3 looks down here. 5. That has become a 1. That has become a 5. We are going to have a party in the corner. Come on, Sven. There we go. That's 3 in the corner. Losing its religion. Trying to finish off the puzzle. 2, 5, 4 in column 1. Surely. What have we got? 6, 7 and 8 to place here. Don't think I can do that yet. Puzzle retains some secrets. This is a 6-1 pair in the middle row. 5, 7 and 8. I can place 7. That's a 5-8 pair. I bet I can finish columns, well, boxes 2 and 8. I can. 4 and 6. 4 and 5. That's become a 5. That fixes this. 3 columns to go. 2 columns to go. That's a 7. Oh, look at that. It's going to do everything. What an awesome machine or puzzle. 45 minutes. I love that. That's so clever. Oh, it's so tricky. I took a good 5 or 10 minutes. Having asked, I thought rather brilliantly, where was 9 in that row? I mean, it was a fairly obvious question once 9 was locked into one of those cells, but it took me a little while. But the counterpart question of where was 8 in that row took me forever and was much easier. And I did all this work on those two, and it didn't need to be done at that point. It could have been done later and been simpler. Ah, it's a brilliant puzzle. What a brilliant idea. Very tricky. 9 bent arrows, 1 straight, and 1 tough puzzle there. Thank you for following along with me. Well done if you solved it yourself first. And wow, have fun with the Jewels of Osiris. Hope to see you on the channel again tomorrow. Bye for now.